Okay, let's take just a minute to look at the graph of e to the x. So here is the graph of e to the x, and you'll notice it looks very similar to the graph of, say, 2 to the x, because remember, e is just a constant, 2.71, blah, blah, blah. So it acts, very similarly to, say, 2 to the x. It's a little steeper. Okay. Now, if we compare that to e to the negative x, well, that would just be e to the x reflected across the y-axis, right? We learned all about the transformations back in Unit 2. And let's just go ahead and talk about how these functions would be the graphs above, but transformed. So if we have f of x equals e to the x plus 2, so that's e and then x plus 2 is in parentheses up here as the exponent. Well, we're adding 2 inside the parentheses with the x, okay, so that's going to be a horizontal shift. And since we're adding 2, we're shifting left by 2. So this function would be e to the x shifted left by 2 units. Okay, next we have g of x equals e to the 0.25x. Now, we've multiplied where the x is. Where there was just x, we now put in 0.25x. So this is going to be a horizontal either shrink or stretch. Now, since it's, we could also think of this as like e to the 1/4 x. And this is going to be a horizontal stretch by a factor of 4. Okay, let's go ahead and look at the next one. So here we have e to the negative x minus 3. Okay, now we've put in a negative x for x, so as we talked about above, e to the negative x is e to the x reflected across the y-axis. And we've taken e to the x, and the subtracting 3 from the end is a vertical shift down 3 units. Okay, so all of the transformations we learned about functions work for e to the x.